Good day. You've just learned about structural isomers, which are fairly straightforward. Now we look at geometric isomers. The only time these things apply are to alkenes, and only certain alkenes, not alkenes. So they do not apply to alkanes, and they do not apply to alkynes. When we look at geometric isomers, we have to look at our structure, and we have to slice it in half. And then we look to the left, and we decide which thing's bigger and which thing's smaller. And then we look to the right and decide which thing's bigger and which thing's smaller. If we can see a difference, and in which this case, if we have both big things pointing up, it's called the Cis Isomer. If we've done the same kind of splitting, but now we end up with the big structure here on the upper left and the big structure on the lower right across the double bond, that is the trans isomer, because trans means across. So that's your introduction to it, and we're going to carry on with two examples. So right here we have something called Cisdo Butane. You saw it earlier with the alkenes. This is going to be identified and explained with some quality pointing about why it is a 2-butene. So we see the butene, 4 carbons. The 2 for the butene means the double bond is between the second and the third carbons. But now we have to look at the cis. In this case, the CH3s are both pointing up. So they're both up, so that means both big structures, because CH3 is bigger than H. Our H's are both pointing down. That's the cis isomer. Now we're going to head over here, and it's a little bit fainter because of some low quality printing. We have something called trans 2-butene. So it's still 2-butene, but in this case the CH3, one is pointing up and one is pointing down. So the two biggest things are diagonally across. We're going to have you point at those two CH3s. Okay, those two groups, whereas we have the little h's, which are diagonally across in another direction. Now, what we can't do, and the reason these things are called geometric isomers, is we can't rotate that around to create this structure. So there's no rotational ability around a double bond, so we can't flip the methyl up and have the hydrogen flip down to generate that. So we made it very difficult for the photographer to have any idea where to look, because I was pointing everywhere. But it doesn't really matter, because I doubt people watch this stuff.
Cut.